For 7.3, day 1, we're introducing you to logarithms. So first of all, the way you read this is log base b of x equals y. So again, log base b of x equals y. This is just a fancy way of saying what is the exponent that turns b into x. The answer is y. So y is the exponent that turns b into x. So I rewrote it in exponential form on the bottom line. Okay, so for number 1, that is in logarithm form, and they want us to write it in exponential form. So remember, logarithms are just asking what exponent turns the base into the bigger number. So log base 2 of 8 equals 3 because 2 to the third equals 8. On number 2, log base 4 of 16 equals 2 because 4 squared equals 16. So remember how to rearrange it. The way I read it is log base 3, so 3 is the base. The exponent is always on the other side of the log. And then the 1/9 goes on the other side of the equal sign. And we can confirm 3 to the negative 2 is 1/9 because 3 squared is 9. 3 squared is 9, so if we want the 9 to go to the bottom, we make the exponent a negative 2. Alright, now we're going the other way. It's in exponential form, and we want to put it in logarithm form. So log base. So what number is the base? Remember that a base is a number that has an exponent above it. So we write 3. 3 is the base because it has an exponent above it. And then remember that the next two numbers kind of trade sides. 81 goes next to the base, and the exponent goes on the other side because a log is always asking what is the exponent. So the exponent that turns 3 into 81 is 4. Okay, base always goes down low. Exponent always goes on the other side of the log. Write the base small. Exponent goes on the other side of the equal sign. Alright, so now they're asking you to solve. So again, this is asking what exponent turns 2 into 16? 2 to what power equals 16? You guys should know from the previous lesson that 2 to the 4th equals 16. So the answer to this question is 4. What exponent turns 5 into 125? Well, 5 to the third is 125, so the answer here is 3. Alright, let's actually pretend that we don't know the answer. So if I didn't know the answer, what I can do is say the answer is x. Then I can change it to exponential form. 5 to the x equals 125. And then it's just like the last lesson. We make the bases the same. If I do a tree on 125, I get 5 and 25, 5 and 5. So it's 5 cubed. And now I get rid of the bases, and I can see that x equals 3, which is what we got earlier. Okay, for number 9, what exponent turns 7 into 7? Well, that's 1, because 7 to the first power is 7. Okay, let's try that other method with number 10. Let's pretend we don't know the answer. Rearrange it. So 8 to the power of x equals 1. We know that anything to the 0 power is 1. I should say anything except 0 to the 0 power is 1. 0 to the 0 is undefined. Anything else to the 0 power is 1. So the exponent that turns 8 into 1 is 0. So anytime you have a 1 here, the answer is going to be 0. Okay, so for 11, let's pretend we don't know the answer. So I call the answer x, then I rearrange it. 25 is the base, x is the exponent, 5 goes to the other side. Alright, 25 and 5, we can make those both have a base of 5. So 25 is 5 squared, and then I still put the x. I can put parentheses here if I want to. This is 5 to the first. So going back to 7.2, we get rid of the bases. We get 2x equals 1, so x equals 1/2. And I'm only going to box the 1/2 because there was no x in the problem. Going back to number 10, 0 is the answer. Alright, 12 is asking, what exponent turns 8 into 2? If you're not sure right away, call it x, rearrange it. Alright, what can we break 8 into? 8 is 2 times 4. 4 can break into 2 times 2. So 8 is 2 to the third. And then put the x with it. And then the right side is 2 to the first power. 3x equals 1, so x equals 1/3. And the reason that's true is because the cube root of 8 is 2. So 8 to the 1/3 is 2, because exponent 1/3, recall, if you have 1/3 in the exponent, that's the same thing as a cube root. Okay, for 13. You guys know that 5 squared makes 25, but if we want the 25 on the bottom, you're going to need a negative exponent. So I know the answer is going to be -2. Let's pretend we don't know the answer, rearrange it. 5 to the x equals 1/25. 5 to the x. Again, we know that 5 squared is 25. So if I want the 25 on the bottom, it's 5 to the -2. Get rid of the bases. X equals -2. But there was no x in the problem. So -2 is our answer. Okay, on number 14, we're going to have to change both. We're going to have to break down both numbers. So first I rearrange it. I put it in exponential form. 4 is the base. Exponents are always on the other side of the equation as the log. 4 to the x equals 32. So I cannot use 4 because 32 is not a power of 4. 4 to the second is 16, 4 to the third is 64. So instead I have to make them both 2's. 4 is 2 squared, Don't forget about the x. 32, if you break down 32, it's 8 times 4, and then those break down into more 2's. If you do the tree, you'll get that 32 is 2 to the 5th. Get rid of the bases, so x is 5 over 2. Okay, so pretending we don't know the answer, 27 to the x is equal to 81. Those are both powers of 3. 27 is 3 times 9, and then 9 breaks into 3 and 3. So 27 is 3 cubed, and there's an x there. 81 is 9 times 9, and then each of those 9's can break into 2 3's, so it's 3 to the 4th. Get rid of the bases, and you get x equals 4 over 3. Okay, for 16, equal it to x. 8 to the x equals 1 over 4. Alright, so what are 8 and 4 both powers of? They're both powers of 2. 8 is 2 times 2 times 2, so 2 to the third. And then 2 to the third to the x. You don't need parentheses, you can put it if you want. You don't need parentheses unless there's addition or subtraction in the exponent. Alright, we know that 4 is 2 squared. If I want it to go to the bottom, I put a negative in the exponent. Get rid of the bases. Set the exponents equal. Final answer is negative 2/3. Okay, 32 and 4 are both powers of 2. Writing it in exponential form, 32 to the x equals 4. 32, if you break it down, is 2 to the 5th power. 4 is 2 squared, so x equals 2 over 5. Okay, 125 to the power of x equals 25. 125 is 5 to the third, and there's an x in the exponent as well. 5 squared is 25. 3x equals 2, x equals 2/3. The back is pretty similar, but they actually put x in the problem, so you're going to solve for x. We're going to rearrange it like we were doing on the front. 4 to the third power equals x, and now we just multiply 4 times 4 times 4, which is 64. Okay, for 20, rearrange it. The base is x, the exponent is negative 2. This number is actually called the argument. The argument is 1 over 25. So you have base, exponent, argument. Alright, so the way I solve that, if I want to get rid of a negative 2, I put the reciprocal in the exponent. So these would cancel out and it would just become x to the first. And now I have to figure out what is 1 over 25 to the negative 1/2 power. So I can apply the negative 1/2 to the numerator. and to the denominator. What do we do with negative exponents? Well, negative exponents can move and become positive. So if I have 1 to the 1/2, let me say that again. If I have 1 to the negative 1/2 on the top, that can become 1 to the positive 1/2 on the bottom. If I have 25 to the negative 1/2 on the bottom, that can move to the top and become exponent positive 1/2. Remember that exponent 1/2 just means take the square root. So the square root of 25 is 5. The square root of 1 is 1, so I don't need to write that on the bottom. Answer is just 5. For number 21, x to the 1/2 power equals 3. So one way you could get rid of it is square both sides. You could also change this to radical form. So it doesn't matter if you keep it in this form or if you change it to that form. You're going to square both sides on the next step anyways. And either way, you get x equals 9. Okay, for 22, the base is 8. 8 to the negative 2 equals x. We already have x by itself. We just need to simplify the other side. Remember that negative exponents can move. So we're going to move that to the bottom. There's a 1 on top. So this is 1 over 64. 8 squared is 64. So 8 to the negative 2 is 1 over 64. Alright, and then finally we have 2 word problems to finish it off. Okay, so for 23, we have an equation. It represents what someone would score on an Algebra 2 test T months after the school year. So once the school year gets out, you probably forget what you learned, so you won't do as well as you would right when you took the test for the first time. Alright, so for part A, what was the student's score at the time the school year ended? So T is how many months after the school year is over. So if the school year just ended, it is 0 months. So we're finding y of 0. So if I'm plugging 0 in for T, I need to ask myself, what exponent turns 2 into 1? So off to the side. I want to solve this. What exponent turns 2 into 1? Well, anytime you have a 1 in the argument, the answer is 0. 2 to the 0 is 1. So this is going to be 85 minus 6 times 0. This whole thing here equals 0. The exponent that turns 2 into 1 is 0. So 85 minus 0 is just 85. So they would score an 85 on the test right when the school year ended. Now, imagine you go home for the summer, don't do any math. What's your score going to be if you take that same test 3 months later? This time we're going to plug in 3 for T. Alright, what is the log asking? The log is asking The log is asking what exponent turns 2 into 4. So right here, this is asking what exponent turns 2 into 4. The exponent that turns 2 into 4 is 2. So we have 85 minus 12. So this person would score a 73 if they waited 3 months and took the test again. Okay, for the final word problem, let's find the equation. So they want us to fill in this table. They give us a bunch of values to plug in for r, and we have to solve for y. So filling in the first box, we have log base 10 of y. We're solving for y. We're plugging 1 in for r. So solving that, we get log base 10 of y equals 0. Rearrange it, 10 to the 0 power equals y. So y equals 1. 10 to the 0 power equals 1. Okay, for the next box, we're going to do the same thing, but we're going to plug in 2 for r. Log base 10 of y equals 2 minus 1. Log base 10 of y equals 1. Rearrange it, 10 to the first power equals y, so y equals 10. Alright, so maybe you noticed that when we plugged in 1, we got 10 to the 0. When we plugged in 2, we got 10 to the first. So when we plug in 3, we're probably going to get 10 squared, and the reason is because we're subtracting 1 from every r value. So 10 squared is 100. 4 minus 1 is 3. The next one's going to be 10 to the third, which is 1,000. And the last one's going to be 10,000. Okay, so this is just trying to teach you that when an earthquake goes up by 1 in magnitude, the intensity gets multiplied by 10. So if you go from 2.0 to a 3.0, the intensity goes from 10 to 100, so that's 10 times more intense. Alright, that's it for this lesson.